Welcome back to Around the World in 80 Telescopes, a live 24-hour webcast that is part of the 100 Hours of Astronomy project for the International Year of Astronomy. You're joining us at the European Southern Observatory headquarters near Munich in Germany as we visit some of the most advanced telescopes both on and off the planet. We saw Gemini North in Hawaii at the start of this 24-hour broadcast, and we're now going to Gemini South in Chile. But before we join them live, let's find out about them in this video.
Exploring the universe, sharing its wonders. These words capture the purpose and essence of the Gemini Observatory, where two identical telescopes explore the universe from both hemispheres of our planet. Gemini's history is one of international cooperation and collaboration. During the last decade or so of the 20th century, what was known as the Gemini 8-meter telescope project began when a subset of the 7 countries that now comprise the Gemini Partnership started planning for the next generation of large telescopes. Today, the result of those efforts is the Gemini Observatory. Its twin 8-meter telescopes operate from the heights of Mauna Kea in Hawaii and a mountaintop called Cerro Pichon in Chile. The Gemini telescopes observe the universe from the infrared or heat radiation from space through optical light that we see with our eyes. Gemini's huge reflectors, which are about 8 meters or 27 feet across, collect this light with mirrors that are unique among the astronomical observatories. This is because the mirrors are coated with a special layer of protected silver rather than aluminum, which is the more traditional coating for large telescopes. This gives Gemini an advantage in the mid-infrared part of the spectrum, allowing for observations that no other ground-based telescope can do. Now, about 180 employees are responsible for nightly observations, maintenance of scientific instruments, and daily observations ranging from accounting to human resources. The staff is recruited from local communities as well as throughout Gemini's international partnership and the world. They coordinate activities from the base facilities located in La Serena, Chile and Hilo, Hawaii. In addition, each of the Gemini partner countries maintain a national partner office to serve our scientific users around the globe. As it was originally envisioned, Gemini operates in what is called Q mode, where each night observations are made from a list that has been prioritized in advance to best match the conditions and circumstances of the sky. In one night, observations could be made from planet hunting to searching out the beginnings of the universe, switching between instruments that are kept at the ready to collect data. One of the things that makes Gemini so powerful is the ability to observe time-critical events, such as sudden, violent gamma-ray bursts. Often, there are only a few minutes of warning before an observation must be made that will catch an event as it unfolds in the sky. Gemini also excels in the search for and characterization of planets in orbit around other stars. Using technology that removes distortion caused by turbulence in our atmosphere, Gemini is able to study those exoplanets at extremely high resolutions. Both Gemini telescopes are equipped with